Hi everyone, Steven here. Welcome to another lecture in this MATLAB crash course series. Today we're going to be covering if-else statements in MATLAB, and this is where things start to pick up a little bit with our script writing, and I'm going to show you why in actually just a couple slides. So the topics that we have for today, first we have what the purpose of if-else statements are. We have using if statements and if-else statements within MATLAB and within our scripts that we write. We're going to look at nested if-else statements and how to utilize those specifically. We're going to look at using the else-if statements or the else-if clause specifically and what all that has for store. We're going to look at using logical operators with if-else statements and how this can enhance how we write these if-else statements. And then we're going to look at the is functions in MATLAB, which are specific functions that allow us to return logical true or false values. So let's begin with the purpose of if-else statements. So in the last lecture, we were able to write a variety of scripts to solve problems that represented certain situations. So like in the last lectures we had, whether that was the plotting lecture or just writing scripts in general, we were able to solve certain problems that were asked of us just writing plain scripts using different concepts that we've learned so far. But these scripts will generally only allow for the completion of a single type of task, meaning that essentially everything we've been learning so far will really only allow for one type of event to happen or one calculation to happen. But sometimes a different action might be needed depending on what type of input the user offers. So take for example, we have a script that simply calculates the area of a circle, and I actually have a few scripts prepared just to cut the time for this video. I have a couple scripts prepared, so let's look at this script I've already prepared. So this is just a script called calc area. This script will calculate the area of a circle given input by the user. So essentially it's very straightforward. Radius equals input, enter a value for the radius of a circle. It asks the user for the radius of a circle. It calculates the area using pi r squared, and it simply prints out the area of the circle. And this is something that would have been able to do using the skills throughout the course of this lecture series or what we've learned so far. However, let's say for example, the user enters a negative value. This would not make much sense in the world of geometry and calculus because a circle can't necessarily have a negative length. That doesn't make any sense. However, if we try running the script, so let's say I run this script here, I say calc area, enter value for the radius of a circle. We shouldn't want to get an area here. It wouldn't make any sense. The radius of the circle is negative in this case, and this the formula we use in the script we have will simply just calculate the area of the circle. But what we have so far under our belt, what we've learned so far, we have no way of being able to tell the user, oh, you entered a negative number. Except for today, I'm going to teach you a few skills that actually allows us to be able to determine this. In fact, MATLAB, along with almost every other programming language that you can think of, allows for different actions to execute using if-else statements that we've been learning. So essentially, here's what an if statement and an if-else statement is. A simple if statement determines whether or not a certain action or a series of actions will be completed. The block to the right here represents a single if statement. And this is how you would type it in MATLAB. So you would type the keyword if, you would type a condition. Underneath that statement, the if condition, you type an action, meaning just some lines of code that you'd like to be completed, and then you type the word end. If the condition specified is met, then the action inside the block will be completed. So if this condition is met, then this action will be completed. It's very straightforward. It makes sense in language that we speak in English. If this is true, if this condition that we have is met, then this action will take place. A condition must yield a logical true or false value. This is important. So the condition here, we've been studying logical values, Boolean values, and these are accomplished through relational operators saying like x is less than 3, y is greater than or equal to 7. The condition must be something along those lines because in here, we need something that will give us a true or false value. If the value is true, the action is completed. If the value is false, the action is not completed. And I'll show you exactly what it means. You have to then enter the keyword end. It's used to indicate that the actions to be completed in the block are over, that we're no longer in the if statement. Everything after the end will happen no matter what. So let's give a really quick example. Adding a fee for an adult at a park. So once again, I have multiple scripts already made just to kind of cut down the time this video has. So parkfee.m is a script that I've created. So this script, if you look here, it calculates the fee to go to a park depending on the age of a person. The price generally is $5.95, but if you are over the age of 13, the price is an additional $3.50. So let's see what this has. So we ask the user for an age. So we say, welcome to the BIW, Best in World, Park. The age is input. Please enter your age here. So that means that MATLAB will say, please enter your age. The user enters their age. The price, originally, no matter who you are, the price is going to be $5.95. But if you're over the age of 13, the price has to be an additional $3.50. Currently, we don't have a way of calculating this based on our current skills, or there are ways we could do it, but they're not as intuitive. But using the if-else statements makes this very familiar, makes this similar to like English, for example. So we say price is equal to $5.95. That's the price, the laydown price. But if your age is greater than 13, age being the variable that the user entered, price equals price plus $3.50. The price plus $3.50 simply adds $3.50 to that price variable. At the very end, we fprintf your total cost is, and it prints to 2 decimal places the value of price. So if your age is greater than 13, it's going to add $3.50. That's essentially what this means. If age is greater than 13, it makes sense in English, essentially. But if you're 13 or younger, price is going to stay the same. And we can actually do this right here as an example. So let's say I run park fee. Welcome, please enter your age. Let's start with saying my age is just going to be 12. So based on our script, the cost will just be $5.95. That extra $3.50 is not added because this block was never executed. This is never executed because age was less than 13. This condition was not met. But let's see what happens. I'm going to type down here. I'm going to run it again. Please enter your age. Let's see what happens if I type 43. My age is 43. Now my total cost is $9.45. It added the $3.50 on. The if statement works. It makes sense. The age is greater than 13 and adds $3.50. We can extend this further and use using an if-else statement. So unlike an if statement, an if-else statement will complete a different action if the previous condition was not met. So in the last example, we only needed one condition. We just need to say if the age was greater than 13, then everything works. But sometimes you want a completely different action to happen. If the condition is not met, then something else completely different will happen. This block to the right over here represents the if-else statement format. So we say if a condition that an action takes place. Then we just say the keyword else, and then we put a different action. Notice there's nothing after else. Else essentially means, okay, if that previous condition wasn't met, then we're 100% going to take this different action here. If that condition was not met, put whatever's in the else. Do whatever's in the else. If the condition is met, just do what's in this block, skip what's in else. So if the condition is met, then the first action will be executed. So this action will be executed if the condition is met, and it won't do what's in the else statement. But if the first condition is not met, then this action, the different action, will occur and will be executed. So let's go back to that previous example I had. We're going to calculate the area of a circle, but we're going to test to see if it's a negative value. So I have calc area 2 here. Let's take a look at this script. I'm going to clear what's down here. Clear. So this calculates the area of a circle given user input for the radius. The script will check to see if the radius is a non-negative value. So the radius must be a non-negative value in order for the area to be calculated. If it's negative, the area will not be calculated. So let's see. We ask the user for the input once again. Then here we check to see if the radius is negative. If radius is less than 0, fprintf, the radius cannot be a negative value. This makes sense. We're saying if the radius is less than 0, i.e. a negative number, then we're going to print that it can't be a negative value. Else, meaning that essentially anything else, meaning if the radius is greater than or equal to 0. That's what qualifies as else. A number can either be less than 0 or it can be greater than or equal to 0. Well, a real number anyway, but we're not going to get into that. So else, area equals pi r squared. Fprintf, the area of the circle is, and then we print it to 2 decimal places. It makes sense essentially. We're just saying if the radius is less than 0, do this action. If it is greater than or equal to 0, complete this action here. Let's see it in, well, action. So we're going to say calc area 2. Enter a value for the radius. So let's just do a positive number first. Let's say the radius is 3.4. The area of the circle is 36.32. Since it was a positive number, it just printed out the area. But let's try again, and let's enter a negative value. Let's say negative 1.2. This value is negative, and since it is negative, it's going to print out the radius cannot be a negative value. A different action took place depending on the number we entered purely according to this if statement. Since the radius was less than 0, it printed out this line. When the radius was greater than 0, it calculated the area and it printed the value. The if-else statement is very methodical. It's a good algorithm to use if you want a different action to take place depending on what conditions you're looking at. Now we're going to look at nested if-else statements. There may be some situations in which a nested if-else statement could be used. Essentially, a nested if-else statement is an if-else statement inside another if-else statement, which might sound a little confusing, but over here on the right, you'll see what we're talking about. If more than 2 different actions can be chosen from, essentially maybe 3 or 4 different actions, an if-else statement can be placed inside an if-else statement. In the block to the right over here, the second if-else statement will only be considered if condition 1 is met. So let's see. So it says if condition 1, then we execute this block in here. But then we have 2 options. We can either say if condition 2 or pick else. So essentially we're saying, okay, if condition 1 is met, then we have to take a look at another condition. If this condition is met, complete action 1. If condition 1 is met but condition 2 is not met, complete action 2. If condition 1 is not even met, complete action 3. This looks a little daunting, but I have another example to take a look at this. You'll see here we have essentially a few different conditions. There's more than 2 conditions to choose from this time. And the nested if-else statement allows us to say, okay, we have more than just one condition to look at, or more than 2 conditions to look at. So let's look at this example here, buffet cost. So this one uses a nested if-else statement. So the script will determine the cost for a buffet for an individual given user input for an age. The costs for the buffet are as follows. So the buffet is $8 for ages 12 and under, $13 for adults that are 13 and up, and $11 for seniors that are ages 65 and up. So we have 3 different conditions here, so we can't just use a normal if-else statement because we have more than 3. So first we're going to ask the user for their age. We say, welcome to the world's best buffet. Age equals input. Please enter your age here. The user enters their age. It's stored in that age variable. Now we're going to calculate the price for the buffet based on what the age was. So let's see. We know for a fact that if it's, if the individual is younger than 13, it's going to be $8. But if they're greater than or equal to 13, we have 2 different choices. That's when we're going to use the nested if-else statement. We're saying if age is greater than or equal to 13, we have 2 different options. It's either $13 or $11 based on whether they're an adult or senior. So we're going to say if age is greater than or equal to 13, then we check again. We say if the age is less than 65, that means that we know the person is greater than or equal to 13, but they're also less than 65. Both of those conditions are true, meaning we are looking in this range here. So based on those conditions, we know the cost is going to be $13. Then we say else. You have to think a little bit for this one. So we know the age is greater than or equal to 13, but we know it's not less than 65. Essentially meaning the age is greater than or equal to 65. It can't be less than 13, has to be greater than or equal to 65, so it's definitely greater than or equal to 65. That's going to fall in the senior category. So that means that in this else statement here, we're going to say cost equals $11. Then we put end. Else, meaning we have to look at this condition here. If this condition was not met, then we execute this action here. So age is greater than or equal to 13. Else, that means that the age was less than 13. If the age is less than 13, that falls in this category for the kids, the children. Then the cost is $8. Then we display the cost, saying your total cost is, we say to 0.2 decimal, we have cost. So let's see this one in action as well. I'm going to run down here just so we can compare what the script looks like to what the result is. So we're going to run buffet cost. Please enter your age. Let's start by being an adult. So if you are 24 years old, you're an adult. If we're 24, let's see. It's going to go here. It's going to say if age is greater than or equal to 13. Well, we're greater than or equal to 13, so now we're going to go here. Then we're going to test if age is less than 65. 24 is less than 65, so that means the cost will be 13. And let's see what happens when we click enter. Total cost is 13. Let's try again. Please enter your age. Let's try if you're a child. So let's say you are 4 years old. If age is greater than or equal to 13, well, 4 is less than 13, so this condition is not met, meaning we jump down to the else block. Since we're definitely less than 13, the cost is 100% going to be $8. Total cost is $8. Let's try one more time. Buffet cost. Please enter your age here. Let's make it a senior now. So the senior's age could be 72 years old. If age is greater than or equal to 13, 72 meets that condition, so we're going to move here. if age is less than 65. 72 is not less than 65, meaning we have to be in this else statement here, meaning the cost will be $11. Your total cost is $11. The if-else statements and nested if-else statements work in a way that's familiar with English. It works in a way in which we can literally see what the result's going to be. We can work down which lines are going to be executed. However, the nested if-else statements can kind of get a little out of hand, especially when you have multiple different options to choose from. It can look a little clunky, but most programming languages, including MATLAB, allow for a different way for us to represent when there's more than one condition, and that way is through the else-if clause. So another way of choosing between multiple different actions is by using an else-if clause. The clause can be used after the first condition in the if statement. So essentially we can type if something, and then if we want another condition to be considered, instead of doing nested if-else statements, we can say else if and then put another condition. So after the keyword else if, another condition is placed to potentially be, to be chosen. Oh dear Lord. To be chosen. Oh geez. As many else if clauses as necessary can be used within the if else statement. So essentially we can put as many else if clauses that we want in here. If we have 50 conditions to choose from, we can make a giant row of 50 different options or 50 different conditions. However, and this is important, once a condition that works is met, that condition will be performed and everything else will be skipped. So that means that once MATLAB finds a condition that works, it's going to skip everything else and only execute that condition. So let's say we have 4 different conditions, and we have an input that allows for the second and the third condition to be considered true. Only the second condition will actually work, and only the second action will be executed. Since that second condition was met, even if the third condition was met, we're not going to have that action be completed in the third block. And I'm going to show an example a little bit later that illustrates this a little bit better. But so as an example for the else if clause, I created another one of the calc area ones. This was a very straightforward else if clause and else if a statement using else if. So this script will calculate the area of a circle given user input for the radius. The script will determine if the radius is negative or if the value is equal to 0. So we're going to have something different happens if the radius equals exactly 0. So first we ask for the radius. We say radius equals input, enter a value for the radius. Check to see if the radius is negative. If radius is less than 0, so then here we actually see what the value of the radius is. If the radius is less than 0, meaning it's negative, we're going to print out the radius cannot be a negative value. Makes sense. Now we have our else if here. So we have another condition. Instead of a nested if else statement, we just put another condition. We said else if, meaning we have another condition, the radius equals 0 exactly. We're going to print a circle cannot have a radius of 0. We're just going to print that out. It's a little bit different. We're going to say it's a point in that case. So if it's negative, this first action will happen. But if it equals 0, this second action will happen. But if it's neither of those two, meaning it's positive, we're going to calculate the area and we're going to print it out. Let's illustrate this once again. So calc area 3. I'm just going to do it when it equals 0. So if I enter 0, a circle cannot have a radius of 0. It works exactly like that. It just finds the clause that works, finds the condition that works, and prints out that action. All right, now we're going to look at logical operators with if-else statements. So as previously stated, the conditions for the if-else statements generally consist of a relational operator. So all these examples have been using the greater than, equal to, less than or equal to. All those are relational operators that are generally used with if-else statements. Many of these relational operators can be combined within the condition by using the logical operators, the double bar, the double ampersand, or XOR. If you remember back in my second lecture, we talked about the logical operators. These represent the OR operator, the AND operator, and the exclusive OR operator. I'm not going to discuss exactly what these operators do. If you want to remember what these do, please check out my second lecture where I talk about relational operators and logical operators. If the final result produced by the logical operators is true, then the action inside the if or else if clause will be executed. So essentially we can combine multiple conditions into one if statement or one else if clause. We need to avoid illegally combining these operators though. Let's say I wanted to test and see if x equaled 5 or x equaled 6. Let's say I want a certain action to happen if either x equals 5 or x equals 6. I want the same action. I cannot write this. This might look as if x equals 5 or 6. We cannot say that. That is not going to give us a legal value. We have to display it as this. We need to say if x equals 5 or x equals 6. This is what will actually work in MATLAB. If we try doing this, the value will actually be true no matter what, and so it's going to create some bugs in our code. So you need to avoid illegally combining these operators. So I have an example in which we can do this, and I haven't actually typed out the entirety of it. So the script will ask the user for the values of x and y for a random point on the coordinate plane. And the user will decide what those values are, and if the values they entered would equal the origin of the plane, meaning 0, 0, it'll specifically specify. So first we ask the user for the values of x and y. X equals input, enter the values of x. Y equals enter the value of y. Then we're going to determine if it's the origin, if the value they entered was 0, 0. So right now, if I were to try to run this, I'm going to have an error because invalid expression. That's because I don't have anything in this if statement. I'm going to actually write that right now. So let's see, what would I put in here? Well, what's true about the origin? Well, for it to be the origin, both the value of x and y needs to equal 0. Both of them have to equal 0, not just one or the other. So in this case, I'm going to use the logical AND operator because both x and y need to equal 0. But this is where some people might end up doing something a little bit wrong. They might end up typing something like this. They might say if x and y equals 0. So they're going to say if x and y equals 0, then this will work. And this is not going to give correct results. In fact, let's try to see what happens. It might work in some cases, but in the majority of cases, it will not work. Let's try to give an example where it would not work. So let's try first by saying, let's make x 5, but let's make y 0. MATLAB said the point you entered is the origin. But that should not be true because x does not equal 0. And this is because we use notation like this. If we want it to work, we need to specifically specify that both x and y are 0. We can't say x and y equals 0. It's x equals 0 and y equals 0. So let's try doing that exact same thing with what we have now. If I said 5 and 0, the point you entered is not the origin. But if I ran it one more time, and I said 0, 0, the point you entered is the origin. So it would only be true if both these values are 0, and that's exactly what we saw. So you need to be careful when using these logical operators, but they can be used to help reduce lines of code. So now we have a couple examples that we can put out here. So my first example, create a script that asks the user for a value to represent their number grade in a class and output their letter grade as following. In between a 90 and 100 is an A, in between 80 and 90 is a B, in between 70 and 80 is a C, in between 60 and 70 is a D, and less than 60 is an F. So let's try to make a code that will specifically look at this. As you can see, we have multiple different conditions to look at, meaning that we're going to want to use the else if clause in this case because we have more than just two conditions. It's going to take more than just if and else. So let's try to make a script here. Make a script, we can save it as letter grade. This script will ask the user for their number grade in their course and determine the corresponding letter grade. All right, first, ask the user for their number grade. So in this case, we're going to want to say grade. We can see, yeah, we'll say grade equals input. We want to ask the user, so we're going to say enter your number grade. So the user in this case will enter the number grade, and it'll be saved as the variable grade. Then we want to determine the corresponding letter grade. So let's try to see exactly what we want to do here. So we know that A needs to be greater than or equal to 90, but also less than or equal to 100. And that's important in this case. Also, we should also specifically specify, let's assume there's no extra credit, so their grade should not be greater than 100 and should not be less than 0. That's going to be pretty important here. So let's see exactly what we could do here. So determine the corresponding letter grade. So let's make an if statement. Let's first have the if statement be that their grade is going to be an A. So we know that if it's an A, it's going to be greater than or equal to 90, but less than or equal to 100. So in this case, we can say that grade is less than or equal to, I'm not less than, yeah. Let's say greater than or equal to, let's actually write it so it looks a bit nicer. So I'm going to say 90 is less than or equal to grade, and grade less than or equal to 100. And this makes sense in this case. Notice that I couldn't just combine all of them together, because once again, that's combining them illegally. So I have two separate things. 90 is less than or equal to grade, and grade is less than or equal to 90. If those two conditions are met, that means that it 100% is going to be an A in the course. So I will say letter equals A. I'm just going to make it a character. And I can say else if, and I can kind of do the same thing. If 80 is less than or equal to grade, and grade is less than or equal to, we can't use less than or equal to in this case, because if it's equal to 90, then it's going to be an A. So in this case, we're just going to say if grade is less than 90, letter equals B. Else if, we can include another else if in this case. Else if, we're going to say 70 less than or equal to grade, and grade is less than 80, just using less than, because if it's 80, it's going to be a B. Letter will equal C. Else if, quite a few else if statements here, but this is completely okay because we have multiple different conditions. Else if 60 less than or equal to grade, and grade less than 70, letter will equal D. Else if, and then in this case we want to be careful because it has to be greater than or equal to 0, because if it's less than 0 then it's invalid. So we're going to say 0 less than or equal to grade, and grade less than 60. Letter equals F. Then we can use else in this case, and if it's anything else, that must mean that it's less than 0 or it's greater than 100. And both of those are invalid input. So we can say else, then we can just say, let's see, what should we do here? We could say, let's say fprintf invalid grade. Just like that in that case. And that'll be completely fine. So then what we want to do is we want to actually print out their letter grade in this case. And so let's just assume it's not going to look too nice in here, but let's just assume that if it's an invalid grade, letter will just equal a 0 in this case. We could actually check to see a little bit later. We can have it print something else, but that'll take a little more code, and we're not going to worry about that right now. So all we want to do is just print what the letter grade would be. So in that case, all we want to do is we could say print letter grade fprintf. Then we could say your current letter grade, and then we could say %C, because these are all characters that we're looking at. And this would do exactly that. This is going to make it so that it's going to check to see exactly what the grade is. And we have to actually put our input in there. And it's going to check to see what the letter grade is given a corresponding number grade. So let's actually try to run this code. Enter your number grade. Let's say they got a B. So that means they got like an 87. Current letter grade, B. We can run again. Enter your number grade. Let's say they got an A. They got a 99. Your current letter grade. Let's say they entered something invalid. So they got a 1000%. Invalid grade. Then we're just saying your current letter grade, it's a 0 because it's invalid. That's all we're saying at this point. Let's see, what's another example? We could have it be an F in this case. So we can say, let's see, what would an F be? An F would be like a 45%. Your current grade's an F. So that's exactly how we would create a script like this. Except this code is not the most efficient way to write things, actually. In fact, there's a way we can write this that would save quite a few characters and a lot of different conditions. Let's try to see what I mean. So essentially what I'm saying is a lot of this is redundant information, meaning we don't need this. If you remember what I said earlier, when MATLAB is checking which condition to execute or which condition is true, it looks for the first one that's true and executes that one. Even if something after it is true, it won't execute that action. It'll only execute the action of the first correct condition. So we can make this a lot different, actually. Here's what I mean. So instead of all of these, we can make this like loads more efficient. So let's see what I mean. So if instead of saying grade is less than or equal to 90, all we can say instead, and then let's assume just for purposes, actually, I'm trying to decide. We actually do need to keep A because A will in fact make sense. So we do need to keep that value for A. So we need to keep this one because of the fact that if they enter a value greater than 100, it's going to print something else. But for B, we can enter something different. If it's B, we can say that the value is simply just going to be greater than or equal to 80. And that's all we need to say, actually. We can just say grade greater than or equal to 80. And this will actually be good enough. This will be all we need. Because if the value is, say, 91, it's not going to go to this else if, even though the condition is met. If the number was 91, it's going to go to this statement here, execute this action, and then skip everything else. Even if it meets this condition, 91 meets this condition, but it already met this condition. So we can leave it as this, and it will get the point across. Likewise, instead of this statement here, we could just say grade is greater than or equal to 70. Here, we can just say grade is greater than or equal to 60. Here, we could just say grade is greater than or equal to 0. We just reduced 1, 2, 3. We just lost 4 separate conditions, and we wrote the exact same program here. It's the exact same thing, because if you look at it, if I entered, say, the number 65, we know that 65 is going to be the letter D. But it meets both this condition and this condition. However, 65 first meets this condition, and since it meets that condition, it executes this action and then skips this condition here. We can actually run this to show. If I say letter grade, enter an 85, letter grade's a B. 85 met this condition, this condition, this condition, and that condition, but it only executed this line because that was the first correct condition that it met. Using that, we were able to complete a lot more efficient code in this case. All right, one of the last things I wanted to touch here is the is functions in MATLAB. So like I said, when you use an if statement or an if-else statement, you need logical values in your conditions. You need to say x is less than 10 or grade is less than or equal to 60. It has to be something to return a logical value. MATLAB has a lot of functions that will actually return logical values depending on a type of variable that you enter. So multiple functions that begin with is exist in MATLAB to return logical values. A single value can be entered into one of these functions, and the function will return a logical true or false depending on whether or not that value is a certain variable type as specified. Let's see what I mean. So examples with the variable var. So let's say we have a variable. That variable is going to be var in this case. Is letter var returns true if var is a single letter. I'm going to actually display all these just so you can see what I mean. So is letter is the name of the function. So let's say we have var equals, and our character is just going to be G. We can say is letter var, and this returns a logical 1 or a true because G is in fact a letter. But let's say I made var equal to 4, and I made 4 a character in this case, not an integer. Is letter var, it returns a false because it's not a letter, it's a digit in this case. Is empty returns true if var is an empty vector. So I could say var equals, and I could just enter brackets, that means it's an empty vector. Is empty var returns true because it's an empty vector. Is char returns true if var is of type data type char. So remember, char is going to be when we have a single character. That's going to be a char in that case. So if I say var is equal to, I'm going to make the character something weird. It's going to be a character that's a semicolon. Then I could say is char var returns logical true because this semicolon is of type character. Is numeric returns true if var is a numeric data type. So that's an integer or a float value. So I can say var equals 0.5, whatever that number is. Then I can say is numeric var returns a logical true. But if I were to say var equals howdy, is numeric var false, because howdy is not a numeric value. Is float will only return true if the value specified is a float value or decimals in this case. So if I say var equals 9.9, is float var logical true. But if I said instead var equals 5, is float var, in this case it returns logical true. The reason it turns logical true in this case is because actually when we say 5, it's not an integer type. Every number in MATLAB is stored as a double. But let's say I were to say var equals int 32 5. Then I say is float var. This case it's false because I specified it as a 32-bit integer. Isa returns true if var is of data type in this case. So in this case, you specify a type as a second input argument in this case. So if I were to say isa, so var is still an int32 type. So I can say isa var, then in as a character vector, I can say int32. I could type like this, and it'll return logical true because var, my variable, is of type int32. It works exactly as we'd expected in that case. So then I have one more example in here, kind of trying to just wrap everything together. So Giuseppe is gathering lake water into a 500-liter vat. He has to move very quickly when filling up this vat because his parents do not support the idea of a 500-liter vat being used as a kiddie pool in their home. So he obtains different volumes every trip. So he's kind of like rushing to put water in this vat. But for some reason, he can measure exactly how much he's doing each time. It's specific. Write a program where the user can enter a vector of different volumes of lake water he's grabbing at different trips and calculate the average volume collected per trip. Be sure to specify if the user entered an empty vector, if the user entered only values of 0, if the user entered any negative numbers, if the values the user have entered have a combined sum of over 500. So if any of these conditions are true, you need to specify that. You won't actually want to calculate the average volume collected per trip. Only if these conditions are not met do we calculate the average volume. So let's create a new script in this case. So we'll save it. We'll call it lakepool.m. So this script will calculate the average volume of lake water collected per trip Giuseppe takes when filling up the 500-liter vat. So first we're going to ask the user to input a vector of all the values Giuseppe took for each trip. So let's see. In this case, we're going to say, let's call it volumes. Volumes equals enter a row vector of the volumes collected per trip. So then once we have those volumes, we got to do quite a bit of stuff to, we got to check quite a few things in this case. So remember, we need to check to see if the user just entered an empty vector. We have to see if the user entered only values of 0. We have to see if the user entered any negative numbers, and we have to see if the user entered numbers that have a combined sum of over 500. So let's see. So we're going to say check different conditions. If all conditions are okay, proceed to calculate the average volume per trip collected. Average volume collected per trip. All right, so in this case, we're going to have to use an if statement and some else if clauses in here. So let's try to see what should the first condition be. So let's say the user entered an empty vector. If you remember on the previous slide, there's a specific function that allows us to see if the vector the user entered is empty. So is empty var. That will return true if var is an empty vector. So we can say if is empty volumes. That means that if volumes is an empty vector, this condition is met. We will say fprintf, please do not enter an empty vector. All right, we have our first condition out of the way, if it's an empty vector. Let's see what our next condition is. The second condition is if the user entered only values of 0. So in this case, how should we do this? So if you remember in previous videos, we discussed quite a few different functions that we can perform on vectors that return logical true or false values. Two of them in particular were any and all. In this case, we're going to want to use the all function. And I'll show you what I mean. We're going to say all volumes equals 0. Remember, what all will do is all will see if every single element of this vector meets the condition specified. So it's going to see if every number entered in volumes equals 0. Let's do a quick example here. So if I said volumes equals 0, 0, 0. If I said all volumes equals 0, this will return a logical true. Because what ended up happening is if you just type volumes equals 0, you get 3 logical trues. What all does is all checks to see if all checks and sees if all of these values are logical trues. If you need a refresher on this, once again go to a previous lecture and see the different functions that we use and specific logical functions we use on vectors and matrices. So this will return logical true. So that means we could say fprintf enter more than just zeros. Kind of being rude to these people, but that's okay. Else if, what's the next condition? If the user entered any negative values. So this, we're going to use that other logical function for vectors. It's going to be the any function. So we can say any volumes less than 0. Once again, this does something very similar. If I said volumes equals -5, 9, 9, for example. Then I said volumes less than 0. I get 1, 0, 0, because that -5, the first value, is the only value that's actually less than 0. What any tests to see is if any of those values has a logical 1 in there. So that means if I said any of answer, I get a logical 1 because it was 1, 0, 0. Logical true. So that's where we're going to use the any function in this case. So that means do not enter a negative value. Any other condition? If the values the user entered have a combined sum of over 500. So this is going to be pretty straightforward to check. Once again, it's an if-else statement. We need to check to see if the sum of all the values is greater than 500. We can actually just straight up use the sum function for vectors, and it will add all those values together. We can check to see if it's greater than 500. fprintf all combined values. Actually, no. All values must have a combined sum of less than 500. So we just had those 4 conditions all checked, and they all are checked correctly. We used logical conditions to check to see if any of these are true. The else will mean that we are in the clear. None of these conditions are true, so we can simply proceed to calculate the average volume collected per trip. So the way we can do that is we can say, I'll make a new variable, average volume, is going to equal, that's going to be the sum of all these volumes divided by how many there are. So we're going to say sum of volumes divided by length of volumes. These functions are discussed more at length with functions with vectors and matrices. So that's going to give us the average volume. Then we can simply fprintf the average volume collected. We can say %. Let's go to 2 decimal places again. 0.2% average volume. And that is going to be everything. This is going to be our completed script for this assignment, for this little mini project here. So you can see we test the prior 4 conditions to see if anything's true. Is it an empty vector? Are all these values just 0? Are any of the values negative? Is the combined sum greater than 500? Testing all these are good ways of testing to see if the user entered a value that they shouldn't be entering. Then if they entered anything good, everything's in the clear, we go ahead, calculate the average volume, and we go ahead and print that calculated volume and using fprintf. So let's actually try this on for size. So let's say I'm going to clear lake pool. Enter a row vector. Let's just do it as normal. So we're going to say 98.4, 2.2, and 45.2. The average volume collected was 48.6. That seems about right. And we can see this worked. Everything worked in the clear. Let's run it again. But let's say our combined sum is a little large. So we're going to say our first value is 300 and our second value is 800. All values must have a combined sum of less than 500. Let's try entering a negative value. So I can say negative 8, 4, 4, 4, 4, 4. Do not enter a negative value. So we can see all these cases that we looked at are going to actually work. And MATLAB, the script that we wrote, is going to check to see if we entered any wrong values or if everything proceeds. What's important here is all these skills that we're learning now are helping us write code that allows MATLAB and allows our script to complete more tasks and do more things instead of just a simple one task, a simple algorithm. We're now creating more complex algorithms. We're trying to see, okay, we have multiple different options. We're going more into the world of a human and how a human would think. And that's where we're going to start proceeding from here on out. Thank you.